Hey guys, we're going to look at modeling with linear functions. And a couple of the biggest things to understand is what the slope and intercept, y-intercept mean in regards to that. So the slope tells us how fast the values are changing. So like how much are you going up or down by? And then the y-intercept tells you how much you start with. So what we're going to do is in our examples today, we're going to look at and try to determine those two amounts so we can write an equation from them. Now exercise 1 says Janine has $450 in an account and she places money in the account at a rate of $5 per week. So in this case, after 0 weeks, she would only have, for here, we know she's getting $5 a week, so it'd be 5 times 0 plus 450, which would mean she has $450. Now after 1 week, she's going to have $5 that's going to be added on to the 450. So using that, I want you to finish these two parts. And then they want us to use information to write an equation. And the biggest part is they want us to use savings and W, weeks, for the equation. So the savings is that value you get out. So we get out savings based on the weeks. And that's going to be equal to 5, because it's $5 per week, 5W. I'm pairing those together, plus the amount we started with, which was $450. Now for C, if she was saving for exactly 1 year. So another thing they tend to have us do on the regions is they want us to take those equations and use them. So 1 year would be 52 weeks, which means that to find the savings for the number of weeks, we could do 5 times 52 plus 450. And then we could put that expression, what I underlined, in the calculator. Now, these are kind of some of the basics that we're going to focus on. We're going to focus on writing equations, and we're going to focus on using those equations to substitute in values. Now we're going to skip over to other parts, and we're going to go to exercise number 2. And we're going to use some of the skills we talked about in the first couple units, or the first couple assignments in this unit, Unit 2. And it says, summarize for part A, summarize the information given in the problem as 2 ordered pairs. So Kirk is driving at a constant speed. He's driving to Denver. After 2 hours, he's 272 miles away, and 3.5 hours, he's 176 miles away. So that means that we're going to have time and miles. We have 2 and 272, and then we have 3.5 for 3.5 and 176. Now they want us to figure out the rate of change. The change in the distance divided by the change in the hours. Well, we know if we do bottom minus top, we have 1.5 hours that went by. And if we do bottom minus top, we're going to have, for this case, it's going to be negative 96 for the miles. So if we do negative 96 divided by 1.5, and again, feel free to use your calculator. Pull it up. Negative 96 divided by 1.5. That gives us negative 64, which would represent the slope for this question, the rate of change. And in part C, it says that, well, you should have found the rate of change was negative. Why is it? So, when we're talking about it, it says he's driving towards Denver, so the distance he's traveling towards Denver is getting smaller. So, what is physically happening? That's the idea. He is driving towards Denver. And they say, assuming this relationship is linear, write an equation for the distance as a function of hours. Now I'm going to use my equation of a line that we talked about. in the last lesson. And I know my slope is going to be negative 64. Well, we'll use the first point. So I'll have y minus 272. And then x minus 2. So I'm going to distribute first, like we talked about. You get negative 64x plus 128. And then we can add the 272 to both sides. And again, if I'm moving too fast, feel free to pause it. So we got 128 plus 272, which in this case, those cross out. We have y equals negative 64x plus 400. Now, that's the equation, but they want us to use distance in hours. So we're going to change this into, actually what I'll do, so I'll go ahead and use a different color. So the distance based on hours is going to equal to negative 64h plus 400. Now, you could be thinking to yourself, well, what does that 400 represent? So 400 is going to be the starting value. That's how many miles he was away from Denver when he started driving there. And then the negative 64, yes, it's negative, but 64 would represent his speed that he's driving towards Denver. So he's losing distance, but in the case of the speed, he's going 64 miles per hour because it's based on those two values, miles and hours, which is our rate of speed. So as you're looking at these examples, think about specific coordinates. Also think about the rate of change, because that rate of change is going to tell you how much it's changing. And then the y-intercept will tell you where you're starting at. So those two are the biggest keys with coming up with equations that we're going to be using in this unit.